Hi, welcome to the concepts in electrical and electronics engineering. So in the first class, we have seen about how do we get electricity to our home, what is engineering, what is electrical engineering, what is electricity, and what is atomic structure. So in this class, we'll discuss about the valence electron and energy band, what is resistivity, classification of materials based on valence electrons, energy band, and resistivity. So what is valence electron? Let us consider a copper atom whose atomic number is 29. So these 29 electrons are accommodated in various orbitals or various shells. So in the first shell, let us consider only 2 electrons are present, and in the second shell 8 number of electrons, the third shell 18 number of electrons, and the remaining electrons are laid in the fourth shell. It is only 1 electron. Actually, why only 2 number of electrons and 8 number of electrons and 18 number of electrons in the subsequent shells? It is based upon the formula 2n square, where n is an integer. So in the first shell 2 into 1 square, that is 2. In the second shell 2 into 2 square, 8 number of electrons, and in the third shell 2 into 3 square and 18 number of electrons are accommodated. The remaining electrons are placed in the fourth shell. So you can define the valence electron as the electrons in the outermost orbit are considered as the valence electron. So in this case, only one number of valence electron is present in the copper atom. So they determine the stability of an atom. So they play a vital role in defining the properties of the elements based upon the number of valence electrons. Even the materials can be classified, whether it is a conductor or an insulator or it is a semiconductor. Next, what is energy band? The range of energies that an electron possesses in an atom is known as energy band. Three important energy bands are observed based upon the number of electrons, how they are distributed. So suppose a valence band and a conduction band and forbidden band. See, some of the electrons may accommodate in valence band and in the conduction band. So valence band. The range of energies possessed by the valence electrons is known as a valence band. The valence electrons are less tightly bound with the nucleus. That means even a small application of the electrical potential is applied, some of these valence electrons are getting detached from the nucleus and they become the free electrons. Once they become the free electron, these free electron can able to travel towards the conduction band, and therefore the current flows in the conducting material. So what is conduction band? These electrons are the electrons which are present in this conduction band are known as a conduction electrons. The range of energy possessed by these electrons are known as a conduction band. And what is the forbidden band or energy gap? You can see the gap between the conduction band and valence band, and this band is treated as a forbidden band, in which, as far as the forbidden band is considered, so based upon the forbidden band gap, even the materials are also classified, whether it is an insulator or it is a conductor or it is a semiconductor. Let us see what is resistivity or electrical resistivity or specific electrical resistance or volume resistivity. For this to explain, let us consider a conductor having an area of cross section A and a length L, which is having a resistance of R. So resistivity is defined as how strongly a material opposes the flow of electric current. Suppose if the resistance, if the resistance offered by the material is high, it is said to be high resistance, high resistivity material. So high resistivity material means it opposes the flow of electrons. So in a high conducting material, the permeability of the electrons is more. A low resistivity indicates a material that readily allows the movement of electrons. The SI unit of electrical resistivity is ohm meter, and electrical resistivity is represented by the symbol rho. It is a Greek letter. Classification of materials. How the materials can be classified? Materials are classified as conductors, insulators, and the semiconductors. So types of classification can be done based upon the valence electrons and energy band and resistivity value. So as we discussed, the valence electrons are the responsible for the classification of the materials earlierly. So here is a general principle: if the valence electron of an atom of material is less than 4, then the type of material is called a conductor. For this, let us consider an example of aluminium whose atomic number is 13. So electronic configuration is distributed as: in the first shell 2 number of electrons, in the second shell 8 number of electrons, and in the third shell 3 number of electrons as per the formula 2n square. So it is observed that these last 3 electrons are in the valence band. So therefore, since it is lesser than the 4, this type of material is called conductor. So if the valence electrons of an atom in a material is greater than 4, then the type of material is called insulator. So let us consider another example: nitrogen whose atomic number is 7. So its electronic configuration as per the formula 2, 5. So 5 are the electrons which are present in the valence band. So therefore 5, which is greater than 4, it is treated as an insulator. Example for insulators are wood and a rubber. So if the valence electron of an atom are equal to 4, it is a semiconductor. Another example, silicon you consider, whose atomic number is 14, its electronic configuration is distributed as 2, 8 and 4 as per the formula 2n square. So exactly 4, it is treated as a semiconductor. The valence electrons is 4, it is treated as a semiconductor. So based on energy band, let us consider these 3 different bands. You can see in case of a conductor, the conduction band and valence band are getting overlapped, which means to say there is no energy gap between this conduction band and valence band. So therefore there is a easy movement of electrons from valence band to the conduction band, and hence the conduction takes place very quickly. Therefore the flow of electrons is easy. It is treated as a conductor. In insulators, we can observe a large energy gap between the conduction band and a valence band. The valence band they are separated. The valence band and the conduction band, they are separated by a large forbidden energy gap. Therefore, there is no movement of electron from a valence band to the conduction band. Next, consider the semiconductor. In a semiconductor, there is a very narrow energy gap between the conduction band and the valence band. Based on resistivity. So in conductors, the resistivity of a material lies in between 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. They is treated as the conductors, whose resistivity is very low, and therefore it allows the more number of electrons to flow. In insulators, The resistivity of the material lies in between 10 power 12 ohm meter to 10 power 18 ohm meter, and therefore it offers greater resistivity. Therefore, there is no flow of electrons. It is treated as an insulator. In semiconductors, the resistivity of a material lies in between conductors and insulators. So it can be of 10 power 0 ohm meter to 10 power 2 ohm meter. Let us have a comparison between the conductor, insulator and a semiconductor. Let us consider the first parameter as the valence electrons. In a conductor, the valence electrons are lesser than 4, and insulator it is greater than 4. In a semiconductor, it is exactly equal to 4. Energy gap in case of a conductor overlaps. Energy gap in case of insulator it is large. Energy gap in case of semiconductors is narrow. Resistivity of a conductor is 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. In case of insulator, 10 power 12 ohm meter to 10 power 18 ohm meter. In case of semiconductor, it is 10 power 0 ohm meter to 10 power 2 ohm meter. Coming to the parameter electricity. In case of a conductor, it conducts. In case of insulator, it doesn't conduct. In case of semiconductor, it partially conducts. Coming to the charge carriers. In case of the conductor, they are free electrons. In case of insulator, no charge carriers. In case of semiconductors, both electrons and holes are present. So coming to the summary, we have discussed what is a valence electron and what is energy band and what is a resistivity and the classification of materials based on valence electron, energy band and resistivity. Let us have a small quiz. The material which contain less than 4 valence electrons are called A. Conductor, B. Semiconductor, C. Insulator and D. None of the above. The answer is it is a conductor. Choose the semiconductor from the following: aluminum, copper, silicon, diamond. So semiconductor is silicon whose valence electron is exactly equal to 4. The material which contain exactly 4 valence electrons are known as obviously the semiconductor. The material which contains more than 4 valence electrons are called obviously insulator. Thank you for watching the video.